So let's talk about scaling. And scaling is a really important step before you do machine learning. And improper scaling biases machine learning training. So what you don't want to have is a feature that has a large numeric range dominating the training. Say I have the age of someone and their salary. Now we hope their salary is maybe a couple of order magnitude larger than their age. You don't want that to be a more important feature just because it has this bigger numerical range than their age. There's no reason to believe at the beginning that that should be. So we scale. And if you don't, you're going to get some sort of strange skew or bias in your model parameters. So how can we scale? So I'm going to just tell you about two methods. There's many others, but the two most commonly used. One that we use constantly is called z-score. And basically we de-mean, so the mean becomes 0, and we divide by the standard deviation, so the standard deviation is 1. This is sometimes called standardization, but z-score scaling. And it's good if the distribution, it's numeric distribution that's approximately normal, and I mean really approximately. It doesn't have to be spot on, but it shouldn't be, 5 modes or something. If you have other distributions that are really strange looking that you can't pretend are normal, min-max normalization might be the best one, or min-max scaling. But it's, so the idea is simple. You simply say, okay, I'm going to do a transformation of the values so that they're in a range 0 to 1, but or -1 to 1 or something like that. But it fails with outliers very severely. You can see if you had an outlier that was 100 times all the other values, all those other values get scrunched into maybe a range of 0 to 0.1, and you have your outlier out at 1. That's kind of ridiculous. So be careful when you use min-max scaling. And that's a general thing. You want to treat errors, missing values, things like that before you apply scaling, because you don't want to contaminate your scaling with the errors and outliers.